The customer complaint is that he starts the vehicle up in the morning, the AC is cold. Within 10 minutes of driving, the AC is warm and it never blows cold again. So what we're going to do is we're going to check out the AC system. Just hooking up the gauges, I already can see it's a little low. But we're going to go ahead and check it out. This vehicle has 190,000 miles on it, and it still has the original AC stuff. So we could just be looking at a little Freon and then some items to beef up the performance of the AC there. So we'll go ahead and check it out now. All right, so we got the vehicle running now. We're looking at our gauges. 50. See, we want to be somewhere around 32. We don't want to be more than into 250 to 300. We want to kind of be there. So we're hovering right now at a low charge state. So the other way we want to verify the AC is working is so we go to the lines. One line's going to be cold. This will be the low side, and this will be the high side. This will be hot. This is the restrictor, the Orifice, right in the center here. So this is where the temperature change is happening. So this is warm, and this is cold. So we're starting to get pretty cold. So being a bad performing system, if the condenser is slow, clogged, it'll keep us from having a good exchange to get the heat out, to get it back to being a liquid for the Freon. But we're kind of hovering. We're not really showing good AC, we're just showing it's working. We'll go ahead and give it a little gas, simulate driving, increase the airflow. All right, so we went through a little bit of a performance test there. What we verified is we just don't have enough Freon in the system. We're low. So we were watching the gauges. We know we gave it some acceleration, some airflow, helping with the temperature change. We never could drop it past the 40. We never built heat up, past the 220 mark, or not even there. So we didn't have enough Freon in the system to make a full change. So we definitely know we're low on Freon. Now we've inspected the vehicle for everywhere there's a connection. If we have a leak, the moisture in oil is going to collect the dust, so we'll have good signs of that. We don't have any signs of leakage or any of that kind of stuff there, so we know the system is just old. I mean, this is a 2000 with 190,000 miles on it, all original parts. So what we're going to do is basically a performance. We're going to put a new dryer in it. A new dryer is the moisture catch, so that's going to make the refrigerant, with no moisture, it's going to be the most efficient it can be. The next one is the Orifice tube. That's the screen, that's the restrictor point. So if it's clogged up and things like that, that's going to be a performance issue there, so we're going to replace that. The other one is the condenser. We're going to do the condenser up front. This is the heat exchange, so this is another big performance part that gets clogged up. So we're going to basically do an AC service as a performance deal for this car. It is Florida. We're almost 95, 100 degree temps already. So we're going to go ahead and take this down to the shop. We have a guy who has all the equipment to evacuate the system so that we can open it up and then we can get started. All right, so we got our vehicle back. It's been evacuated, so what we're going to do now is we're going to do the condenser first. We're going to replace the condenser, so we want to remove this shielding right here. There's a couple clips that we got to remove. All right, so we're going to go ahead, this is the condenser. Right here is what we're trying to remove. So we have two line attachments on this side. One up here, one down below. We have two mounting points. It slips in at the bottom. And we just have to make it past this piece here. So what we're going to do is we're going to go ahead and remove these two mounting tabs here, these bolts, and the bolts behind here, and then we will work on the lines, and hopefully there's enough room to get that out of there. Okay, so we'll go ahead and loosen up our lines now. We got another bolt. Okay, so now we're all loose. All right, so we don't really have enough wiggle room. Yeah, we could probably force it out and maybe force the new one in, but we want to try to not do any forcing. So we're going to take some more stuff off. We're going to remove the grill. We may have to remove the headlights. The goal is this bar has 2 bolts down in this area. We can remove this bar, we can proceed, so that's where we're at right now. We're going to go ahead and remove the grill. There's a couple screw locks. Basically just turning them and they pop out. And we have our ends are we'll go ahead and show you how the headlight comes out first. For the headlight to come out, we got these pins, one here, one here. And our headlight will pop out. Connections. Just releasing the bottom headlights, letting them hang. That gets us our 2 bolts. Now we have a lot of room there. If we could pull out the bolt. Okay, so you can see it's nothing too bad there. Here's another point of AC performance. So this whole section right here, we have no airflow going through, so that includes the condenser. The air may be able to go through the condenser, but it stops. So the air stops flowing through the condenser. That stops the heat exchange. So cleaning all this is definitely going to improve the situation. So they make brushes and things like that. We just got to be very careful so we don't bend up these little fins in here. It's very fragile stuff. We want to keep it as straight as possible for the air to flow through it. So we'll get a brush and we'll kind of brush it this way, down or up, so we can keep the line straight. All right, so here we have our new AC condenser we got from Auto Parts Direct U. All right, so this is the original one we pulled out. So everything looks good. So we have new grommets, so there's a grommet somewhere we're going to have to pull off on the vehicle. Everything looks good here. All right, so we'll go ahead and we'll reinstall our new condenser. All right, so we'll go ahead. The condenser sits down in these little rubber bushings down here. They'll be lined up with the edge, so we'll go ahead and we'll slip this in. There's our other rubber grommet. So we want to be very careful. All right, so we have it kind of sitting over this way a little bit because we're going to put the line on first. So we have our O-rings. We'll get our new O-rings. All right, so we've got our O-rings on. Got a little bit of lube. We'll go ahead and line them up. Alright, so now we bring our condenser carefully back over. And get our line bolts started. Okay, so that's this part of the repair. Now we're going to go ahead and replace the accumulator and the orifice tube. All right, so now we're going to remove the accumulator. So the accumulator is going to be this bolt and this bolt, but we're also going to remove this line here because we need to undo this fitting. This is where the orifice tube is, right here, where this kink in the line, that's the stop for it. So we'll go ahead and remove all of our connection points. All right, so I'm going to go ahead and put this line back on this stud right here. And this is just to keep the shape of the line. Sometimes these are pretty hard to break loose. That's why we're doing it right now. So we want to remove this fitting here is what we're trying to get to. So I try to go back and forth to clean it up. There we go. You can see all the corrosion coming out of that fitting. Anytime you have moisture and two different kinds of metals to come together. You know, this thing's been tightened so tight. There's a little mushroom there. Our orifice tube is right here. It's stuck back. The tip is about right here. So we have a small pair of needle nose. We'll get it inside there. What we want to do is try to see if we can catch the outside and twist it and pull it out at the same time, because if it breaks, whoo. All right. All right, so we're looking good. A little concerned by that first fitting and how the color of the oil, but that's not that's pretty good right there. So we didn't, like, signs of dirty would be the compressor came apart, or the accumulator bag has busted. All right, so here we have our new orifice tube. So they do come in different colors, so we're replacing black with black. So we got a new O-ring. All right, so what we'll do now is we just want to lube up our stuff. Okay, so this is PAG oil. Just going to put a little bit on the orifice there. And then we'll go ahead and put the orifice back in. So you got a little bit of oil everywhere. Go ahead and put that back in. And then we'll go ahead and work. We'll put our accumulator in first, and then we'll put that line in right after that, so we can work downward. All right, so here we have our new condenser we got from Auto Parts Direct to You, or let me start over. Here we have our new accumulator we got from Auto Parts Direct to You. So what we're going to do is, one, we have to transfer the low pressure switch over. And then also we have a heat shield. So we'll go ahead and take the pressure switch off. All right, so then try to peel this thing off without it falling apart. All right, let's see what we can. All right. All right, so we do look a lot alike. Everybody's in the same directions. All right. All right, so we'll go ahead and put our piece on first. We're going to go ahead and put just a little bit of hag oil in. So all the oil should be down at the compressor. We shouldn't really have to worry about this. We'll just go ahead and put just a, just a little bit in there. Just because this is a new accumulator, so it is going to absorb some oil. So this one's saturated. So we want to kind of replace what we think we're taking out. We've got our system all back together. We're going to put it under a vacuum. We're going to put a vacuum on it for about 30 minutes. So in 30 minutes, we should have 30 inches of vacuum. We'll go ahead and we can turn off the system, close the ports, and it should be able to hold that vacuum indefinitely. This is a way to check for leaks. So if you turn your vacuum source off, close your valves, and your vacuum drops off, something is wrong with the system. It is leaking. It's pulling in. All right, so we'll go ahead. We're going to turn the compressor on, the vacuum pump. As we open the lines, it'll pull. All right, so we pull the vacuum. What this is doing is this is removing the moisture. So it is putting the system under a vacuum. It's boiling the water, the moisture out of it, so that way we can put Freon back in and not have any moisture in the system. So we'll go ahead, we'll do a quick check just to make sure everything is. So we've turned our valves off, our vacuum has stayed, it has not dropped off. That's a good sign, everything is tight, so we'll go ahead and apply our vacuum again. And we're applying on both sides, high and the low, because we have a restrictor in the center, one being the Orifice, which is kind of an open restrictor, but the compressor is a closed pump restrictor. So we want to pull on both sides, make sure we get all the moisture out of the system. All right, so here we've let the truck sit for about a half hour. The vacuum pump's still on. We're going to go ahead and close our gauges and turn our vacuum pump off. So right now we'd be at the maximum amount of vacuum pulled, so our needles are pinned and they're staying there. So this is telling us there is no leaks in the system. It is holding a vacuum. Okay, so now we're going to go ahead, since we're under a vacuum, we're going to go ahead and shoot some Freon in it. Since we're shooting with a can, this isn't with a machine, so we spent a half hour trying to get the moisture out because that improves the system. So now we have, basically we put our can on, this, we had atmosphere in the line. So we're going to go ahead and just crack the line right here just to freshen the line up so we don't get any of that into the system. Maybe. All right. All right, so we're going to go ahead and shoot it in. So we always want to charge on the low side. We never want to charge on the high side. We always want to charge on the low side. You can see our high side is creeping up. So this system takes 2 pounds. So these are basically 1 pound cans. So it'll take some of it. Now what we're going to have to do is we'll turn the system on. We'll turn the AC on. That will have the compressor pull the Freon out of the can. All right. Maybe. All right, so we'll go ahead and start it up. Alright, so our compressor cycled. We're going to let it pull our first full can in. We know it needs it. So you can see our compressor cycling. So right now the compressor's off. So once the pressure rises high enough, it'll click back on. This would be short cycling. This is an extremely low system. We're not even a pound. We're not even a half of the system charge. What we want to do is I always put the can somewhere in the airflow. It's sitting on the radiator hose. The radiator hose is getting warm. What that's doing is that's changing the liquid to a gas, increasing the pressure so that it will help it pull it in. So you can see where we were before when we first started. See, we're not even 1 can in yet. So right here, see the compressor's off. Our pressure's at 100. On, our pressure goes up. Once we get more Freon and it quits short cycling, it'll balance out. Okay, so we got all the Freon charged. Everything was looking good. Our temperature drop was pretty good inside of the vehicle. Ran about 10 minutes, and then the compressor kicked off. This is the exact concern, other than the AC wasn't blowing very cold, but this is exactly what the customer was doing. So we had to bring the system up to full charge to be able to diagnose that, because if we had low charge, we could explain that problem, but being at full charge and then we still have the problem. So what we had to do is, one is, do we have good signal? So we went back to the relay box for the compressor relay. We had our 12 volts on our power side of the relay. We had our good signal 12 volts and ground from the vehicle head unit telling the relay to come on. So then we put the relay back in, we come back down to the compressor, and we take the plug off of the clutch coil. We have 12 volts coming from our relay, but our ground side's not there. So I check the positive side of the connector to chassis ground, 12 volts, no problem. So the ground side, where does it go? The ground side goes back to the low pressure switch, and then from the low pressure switch to a ground. So when the low pressure switch is not working, it cuts the ground off, which cuts the cycle off, which stops. So this is a pretty typical problem for Chevy or most cars, the low pressure switch being bad. So this one here, just messing with that switch, it started working again. So it probably won't work more than 10 minutes again, but at least we've isolated it to being the ground issue of that connection being the low pressure switch. So what we're going to do now is we're going to basically tell the customer this. The customer's going to have to make the decision. Replace the switch or replace the whole compressor together. That's, 190,000 miles, first service, this is all, how long do you want to go? So for right now, we're all done with this repair. All right, so today we're working on a 2000 Chevy 1500. The customer complaint is that he starts the vehicle up in the morning, the AC is cold. Within 10 minutes of driving, the AC is warm and it never blows cold again. So what we're going to do is we're going to check out the AC system. Just hooking up the gauges, I already can see it's a little low. But we're going to go ahead and check it out. This vehicle has 190,000 miles on it, and it still has the original AC stuff. So we could just be looking at a little Freon and then some items to beef up the performance of the AC there. So we'll go ahead and check it out now. All right, so we got the vehicle running now. We're looking at our gauges. 50. See, we want to be somewhere around 32. We don't want to be more than 250 to 300. We want to kind of be there. So we're hovering right now at a low charge state. So the other way we want to verify the AC is working is so we go to the lines. One line's going to be cold. This will be the low side, and this will be the high side. This will be hot. This is the restrictor, the Orifice, right in the center here. So this is where the temperature change is happening. So this is warm, and this is cold. So we're starting to get pretty cold. So being a bad performing system, if the condenser is slow, clogged, it'll keep us from having a good exchange to get the heat out, to get it back to being a liquid for the Freon. But we're kind of hovering. We're not really showing good AC, we're just showing it's working. We'll go ahead and give it a little gas, simulate driving, increase the airflow. All right, so we went through a little bit of a performance test there. What we verified is we just don't have enough Freon in the system. We're low. So we were watching the gauges. We know we gave it some acceleration, some airflow, helping with the temperature change. We never could drop it past the 40. We never built heat up, past the 220 mark, or not even there. So we didn't have enough Freon in the system to make a full change. So we definitely know we're low on Freon. Now we've inspected the vehicle for everywhere there's a connection. If we have a leak, the moisture in oil is going to collect the dust, so we'll have good signs of that. We don't have any signs of leakage or any of that kind of stuff there, so we know the system is just old. I mean, this is a 2000 with 190,000 miles on it, all original parts. So what we're going to do is basically a performance. We're going to put a new dryer in it. A new dryer is the moisture catch, so that's going